Hello, everybody. Happy to talk about the lecture 11. This time we'll continue talk about another issue about distributed primitives. This time we'll program a new system, a new distributed framework. As we talked about before, distributed primitives is used to construct some fundamental distributed system or framework. And so, although the system is simple, I think it's still distributed DP or DP is still powerful, and it saves you a lot of effort to programming the same system if using compared with a traditional distributed techniques such as Java, standardization, C or C++ or Python. Yeah, it saves a lot of efforts. So you can see that in the last classes, yeah, we program a TNCS, two node client server, just two node server they can interact with each other. And the last class we it took me about just less than 2 hour, about one more than just one maybe 90 minutes, right? However, if you program with a traditional programming language, it must last very long, and most programmers might not have the sufficient skills to do that because the concurrency issue, resource management issue, distributed knowledge problem, and serialization, network programming, scheduling. There are a lot of difficult issues for developers to program such a simple system. This time we'll program another one. I still use distributed primitives. This time, this system called MNCS. MNCS means multiple node client server. That means in the last time, the total number of code is a total number of nodes, distributed nodes, only 2. But this time, we have multiple nodes. They can form a little bit more complete distributed system. Multiple node client server. So we'll create a new system in this time. However, to do that, we still use DP. Maybe in the next classes, in the future classes, we'll use some other ways to do the same thing. But I think through this procedure, you can understand distributed primitives in detail. Although distributed primitives, when you program them, it's still you need to know something details. It took you more efforts than some future technologies, but in GreatFree, but I think it's fine, yeah, and it's compared with a traditional system, it's still good. It's good enough, right? So this is the definition of MNCS. It's multiple clients in such a system. Multiple clients need to interact with each other. But the distributed architecture is a client server. It's still client server based distributed architecture. As you have seen in the previous classes, the server we use CS server. This is an API and design patterns. We have such API and design patterns. When you use CS server to program the server side, the server can only receive message and generate response passively. So, and in contrast, a client can only send a message and notification or request, and if the request is sent, a response can be received. The server can do something, the client can do something actively, but while the server can only do something passively. However, here our requirements is that multiple clients need to interact with each other, right? So, but if the client if a client can only send a message out to the server can receive a message. But if we require clients can interact with each other, the client cannot send if a client want to send a message to another client directory, is it possible? No, it's impossible, because a client can only receive response upon a request is sent to the server. So the client can only receive message until a request is sent before. This is a ping-pong style in the network programming, such as the TCP protocol. When you use the TCP protocol to programming a distributed system, programming a network or communication, if a connection is established, a client and server can only interact with each other in this way, ping-pong style. Ping-pong. That means client, no interaction exists between client. Enough says the client is constructed in synchronous remote eventer or synchronous remote eventer and the reader. The three API are the fundamental distributed perimeter API at the client side. They cannot interact with each other. So if so, what we can do how we can meet our requirements for this class MNCS? So if so, we have another solution. Each server can play the role of the broker. It keeps all the message, chatting message, or other some request on the server, and the client will send a polling request to access those messages. Then if the client sends a polling request to the server, a response can be generated. If new messages, chatting messages, such as chatting messages are available, then the chatting message can be sent to the client as response for the polling, right? That's the solution. So in such a system, if we want to build a system that clients can interact with each other, then we can just using such a solution. The server is a broker, and the client send a request, polling request periodically. To do that, that's a solution, right? I think this model is very popular. It's a very popular. There are a lot of system. For example, the web system, emails. A lot of system over the internet use such a system, using such a framework, and even in enterprise, within enterprise, there's still some email. Email is a system within enterprise. Even the enterprise system is the distributed in computing environment stable, and the computing resources are rich enough. Even in such a stable computing environment, such approach, such framework, MNCS is still popular. So that's our solution. So I have already implemented such a framework. in GreatFree. In GreatFree, in this code, you can download this code from the GitHub, and despite some distributed primitive APIs and some more complicated APIs, such as I call it advanced APIs, and some design patterns, I also create a lot of frameworks. That this framework is constructed using distributed primitive or other advanced APIs. So because a lot of people, a lot of developers need to, they do not care about what they do not, usually they do not want to construct a new framework. They just use some existing ones, some popular ones. So some most popular distributed framework are established using GreatFree techniques. So MNCS is one of them. MNCS is one of them. If you want to take a look the code, if you want to use MNCS as a distributed framework to construct your upper level application, you can find them here, right? You can find the distributed framework of MNCS here. It's called multiple node, CS, it means client server, right? DIP is a framework. You can understand DIP as framework. DIP stands for distributed infrastructure. DIP here, distributed infrastructure, framework, infrastructure. Okay, framework. This is DIP. You can understand it. Maybe it's just a framework. That's fine. Yeah. So when you say DIP, that means DIP in the package name. When you say DIP, that means that's a framework. So you can follow. If you follow this framework, if you don't want to change the framework, if your distributed framework have the same distributed computing environment as the MCS, you can reuse it, you can employ it, and create your messages and process this message on the server side, and the client can interact with each other through the polling approaches, and then a distributed framework of distributed application can be constructed. We will show that later. For this class, I will explain the code. Let us to discuss the code. Go through the code and run the system. And in the next classes, I will show you how to program, how to reuse, how to work on this framework to build this application. So this is what we want to do in this class and the next class. So let's take a look at here. Okay, this is the first. This is a starting point. You'll see this code. You must be familiar with the code right now, right? This is a starting point. It's a starting point. This is the first. We call it IP. IP means SP. SP means starting point. This is the first distributed primitive design pattern, right? Okay, let's continue. Click here. Open the server. This is also a pattern. You can see this code is almost identical to what we do here. We have create such one application in the previous classes, right? We can take a look at this. This is the starting point we created last time. and you can take a look, the same format, right? Then if you open it, open the business server we created last time, and then we open this server. The pattern is all identical. This is the pattern. This pattern we call CSS. The code almost identical there because the design pattern CSS. Then this application we created last time is simple, but here it's a little bit complicated because there is some this is the chatting, their interaction is performed between a client. More messages are available. Here some upper level application code is created. This code here, because this is a stop method, so all this code here need to dispose their resources. It's almost the same, right? But for this class, for this demo, it's simple because we have no so much time in the class. So the upper level application code does not exist. We do not provide anything on the application level. So no code is shown here for application. Here, star. This line is to initialize the chatting sessions. So here we put a code for the application. Things here, there are two service CS server and two service dispatcher. So this one for chatting. This one is for management. MAN stand for management. So this one you can see last time the server is not stopped. In the last class, at the end of last class, you must see that the server is not stopped, right? Server is not stopped. Here we use this one, this dispatcher, to receive the shutdown or stop message from administrator. I will show that later. And so this dispatcher is used to provide for the to process incoming message for management. However, this server, dispatcher, or this server is used to process incoming message for the application. So that's why I want to create two instances of server. You can combine them together, it doesn't matter, right? That's the same. But if you have various type of message, it's better you can create multiple dispatchers. So it's make code more clear, right? Especially if the message is huge, a lot of different messages to be processed. Maybe, for example, in one of my systems, I use GreatFree to design a complete system. There are more than 100 lines message to be processed. 100 type of message to be processed. So the server dispatcher become a little bit complex. It's better for you that the code is long. The code is very long. So in this case, it's better to create, classify all the messages and design different server dispatcher. That's a good habit to program your code, right? And then the code looks more cleaner, right? Here this time, now because there are two instances of the server, so after we need to initialize here, set up some constants for the parameter, and then we start up the two server. Okay, that's the same. The code is same, although this one is complete. It's more complicated because it's some application code and there are two instances of the CS server. However, the constructor, no, not constructor, now the code structure, the structure or design pattern is the same. This design pattern we call CSS, right? So next, let's open this one. This one should be a little bit complicated because all the message should be processed here. You can see here 1, 2, 3, 4, 5, 6. There are 6 type of message to be processed. However, for this code we programmed last time, only 2 messages. One request, another is a notification. For this case, in this case, there are this request, 4 requests, 2 notifications should be processed concurrently at the server side. Although there are more messages to be processed, the code structure or the design pattern is same, right? Design pattern is same. So you just follow the same identical design patterns to program various applications rapidly. Last time you can you can see how I program this application. Follow example, the chat 2-node chatting. You must see I follow that example and copy paste the code and make some replacement. So to construct this application, that's the same, right? That's the same thing. Now, why we can do that? Because of the design pattern. So this code should be, I don't need to explain that in detail. First, we can take a look at the message, right? The message here is a request. That's the same thing, right? It's the same thing. That's because of the design pattern. Response. All the message when you program with a DP, all the message should derive the server message as its parent. And there's a stream, yeah. Stream is the same, yeah, same format, same dispatcher. Oh no, same design pattern. This is the code to process incoming request. This is a thread. It's a thread to process incoming request. This is another one. For chat registry. Chat registry means when a client want to access the chatting system, the client need to register itself, the username, some password, some description, right? So after the message is received, a account is created on the server side. You can see here is a account is created. This is just the account may be transmitted between the server and the client, so the account need to be initialized. That's the same thing here, right? Because the book need to be transmitted, so the book should implement the interface of serializable. Here, chat partner request. The client need to check whether a friend is available in the chatting system. So it sends such a request to the server. And here, and when this request is saved, the server side will check the account registry to detect whether one particular account is available or not. If it's available, a response is generated. If not, another response is generated, and then this response is sent back to the client. So this is the add partner notification. That means that's a notification. So here, notification, that's the same, right? Notification. The format is same. Then this thread, we'll take a look at this thread. This thread. If one partner is added, that means those two friends or two users need to chat. So a new session is created here. This is also upper level application. So I do not explain this code because it's application. So I just focus on the distributed computing environment. So here, a new session is created because one client send another send to the server, and they want to become friend of another one, so they can interact with they can send a message, chatting message. They can interact with each other together. Okay, this message is more important. This one is both of them. This is called Paul new session request. This is a message that should be sent periodically to ensure a new session is available or not. If the new session is available, then it's possible for them to interact with each other. Right? Here, let us to say what happened on the server side after the polling message received. It checks this private chatting session class and detect whether a new session is available or not. And if then a response is sent to the client, response is sent to the client. After that, this is Paul new chats. If the chatting session is available, then the chatting message may be sent between the server and between the server, right? The client, and the client sends a message to the server. Server keep all this message, and another client may send such a request. Send such a request to the server, and if the new chatting message is available, then it will send to the client, which just send the polling new chats. Here, if a polling message available, if a chatting message available, response is generated. If no message available, send the empty message to the client. Okay, this one chat notification. Chat notification means the one client want to talk with another one, and the message have to be kept. Have to keep on the server, right? On the server. So all the message, the chatting message, is kept in this upper level application code, private chatting session. And this message can be obtained when a polling message, new chat request is received. So that's a code. I think in other code, it's easy to understand them. Although the code looks a little bit long and multiple parameters should be set, right? But I think the code structure is easy to understand. But it looks a little bit complex and not so clean, right? In the future classes, I will try to improve the code here. Here, you can see here all the dispatchers should be disposed. here, that's the same thing, right? Dispose. And for the process method, there are 6 messages to be processed on the server side. There are 6 switch case statements. This for registry, this for chat detect partner. This one is for add partner. This is designed for polling. This one polling new session. This for polling new chat message. This is the message of the chatting message exactly, right? This message should be kept on the server. So the server side is, although the code is difficult, there are a lot of more code than here, but the structure, the design pattern is the same. So the server side is just like this, right? Now let us take a look at the client side. The client side is easy. As the typical type 1 implemented with the DP, the synchronous remote eventer, the synchronous remote eventer, and the reader. The client is the same. A little bit difficult is here. We need to use scheduler. Scheduler is I use one of Java API. It's called schedule thread pull executor. So this one is actually is a scheduler. I use the Java employee from the Java standard edition. Here, so I do not. This is not a fundamental API because I use Java, right? That's actually the Java. So some parameter should be set here. This is also upper level application. Maintain some username, partner name, so they can interact with each other and specify the name, the username. Just so this is also application. So the chat, this one is available, submitted, this task will be executed. You can see here this code will be run periodically. This is the checker. This here run. This is Java standard code. So when you use scheduler to do something periodically, you need to just create such a thread, because it implements the interface roundable, right? Okay, so that code is easy. That's not distributed primitive code. Here I create a simple menu because there chatting happen between the server and the multiple clients. So for you to understand the procedure conveniently, I create a simple menu. Then after that, if the chatting is ended, all the stuff need to be shut down, dispose. Okay, that's easy to understand. Chat reader, let us take a look at this. This API is one of the distributed permitted API called remote reader, right? So you can see here, get this response. After this registry request is send. This is the chat partner request. This is for polling request. This one is also for polling, but this one check the if message chatting message available or not. So this remote reader is a very important one, right? Because file request should be sent using remote reader. Another one we take a look at eventer. You can see I use asynchronous event. In this time, in the previous class, I use synchronous remote event. However, for this application, I use asynchronous remote event. Things when, for example, if you want to chat through your smartphone, and when the button is clicked, and the message after you tap the message, when I click the button, the message will be there in the user interface. So interface, if we use the synchronous remote eventer rather than asynchronous remote eventer, the button might got some problem, got stuck, because their networking happened on the line. If the network is not fast enough, if the latency is long, then the interface got stuck. It's not good, right? So in this case, it's better to use a synchronous remote event. To do that, some additional API. This is not included. This API are not included in distributed Premium API. However, they are important for us to initialize a synchronous remote eventer. This synchronous remote eventer looks a little bit complicated than this one, right? If you just use synchronous one, the code is simple, but here the code is a little bit complicated. A lot of parameters should be set. And then when you want to send a notification here for synchronous approach is easy. However, if you want to do that with a synchronous remote eventer, you need to check if it's ready, and then if not, execute it, and then the notification is sent. Here, that's the same thing, right? Detect here, execute it, and the notification is sent. This one is the more complicated for its synchronous or concurrency feature. So here is this is because a synchronous remote event is used, so the code at client become different from what we have done in the previous classes. But I have talked about, you must understand the pattern, right? In the previous classes, you must say the design pattern called ARE. ARE stands for asynchronous remote eventer. So that's almost done, right? However, there's still one piece of code we have not talked about. This should be this one. I think there are two server dispatcher at the server side. So this is the last message we want to talk about. This is the shutdown server notification. This is for management, not for the chatting application. So I create another server dispatcher for it. So when the shutdown notification is received, it's processed by this thread. This thread will invoke the stop, and then the server is terminated. Last time, this code being the server, for this code, this stop is never invoked, right? It's not invoked. However, here, for this server, when this message received, and then this one is called within such a thread. We can take a look at this. Right, this is a stop. This stop is called. However, this one is not called. if when this is called, then the server can be shut down. So that's the difference. But who sent this message? Which client sent the message? There are a lot of code use this message because in the future classes, all the servers should be shut down properly. So this message reused a lot, many times. So you can take a look at one example. Maybe here is an example. So this one, we can use a synchronous remote eventer to send such a message. It's the same thing. Remote eventer, a synchronous remote eventer is difficult because to be initialized because a lot of parameters, right? So here we can send such a message to the server. The server can be shut down. Notify shut down the chatting server. Okay, I think all the code are explained. I think in the future classes we do not need to explain that again in so explain such things in detail because we have seen many times until now, right? A lot of time when I see such structure, such code design patterns, the thread and the request, notification request, thread creator. I see a lot of many times. So you must get familiar with that. This is not the first time you see this code. So you can, although it's still need to program many code, not much code, I don't think the procedure is complete. Now the procedure is a straightforward. You just make copy, paste, and replace, actually. So next we will show how to run it. Let us take a look at this code. This project, how to run it. The server must be this. Okay, access the server. Wind. There is a directory called multiple node TCP. Here we access the server with another terminal. Primitives. Multiple node. Maybe this one is server. We can open this server first, and we open another one. This one can play the role of the client. Think that at least 2 clients is required to perform this demo. Primitives, multiple node, client. Okay, let us open this one. Start the server. Server started, right? Then you can see here, let me tell you here. Here there is a project called admin, right? This project is used to shut down the server. We'll run it later. This is a client, right? So we enter the client and the client directory, run it, and run this one. So these 2 terminal will interact with each other. Maybe this one name is GreatFree, his friend name LB Lives, and this one is LB Lives, and there's a friend It's GreatFree, registry. You can see something happen, right? Polling new sessions. Think that if no new session is available, it's not necessary to send a message of new poll, new chats. Now it's this message for polling new session. Register. Each one is register, right? After register, that means this one register. Okay. After registration, then this client, for example, this client can search its friend. The second option can search a friend, LB Labs. Search. You can see LB Labs is a great and free guide. There's a description for LB Labs because LB Labs already registered. Okay, search another one. Search GreatFree. GreatFree is description for GreatFree is displayed here. That means the two, actually, this interaction between the two clients, right? One sub registration, after registration, another client can access its information, right? Add a friend. Add friend means a new chatting session should be created. You can see here some message is displayed here. That means the one chatting session is available. Those two users can interact with each other. This user also add friend. Then they become a friend and they can interact with each other. That's the same thing happen on the smartphone, using smartphones. When the smartphone, you use smartphone to connect one friend, you check it whether it's available on the system, and then send the invitation, right? Okay, now let's start to chat. As a sub-menu is displayed here. Type message, hello. Hello. You can see here, Paul new chat request received, right? Okay, hello is received. That's great. Okay. Start a new chat. How are you? Because the polling message should be sent to the server periodically. So there are latencies. Latencies exist. So it's not so instant. If the latency is paired, the length of paired is not so long, it's fine. If the paired is long, then the instant issue maybe not. Instant can be an issue, right? Instance is not good. If you want to interact with each other as soon as possible, then the polling may be not good. But for the chatting application, that's good enough usually. Okay, let's check again. Send a sequence of A. It takes long, right? A is received. The sequence of B. Okay. So this is a demo. It's a suspect. This demo is show you successfully. Okay, so we can exist the client. One problem still exists here, right? Because the server is not existed. To do that, we just enter this directory to execute. To execute the administrator stop chatting server. So that's the first one. Okay, server stop. Okay, thank you so much. That's all for today. Next time, we'll talk about how to create your applications based on the MSS. Okay, that's all for today. Thank you so much.